What's up guys, welcome to my channel. In this video I'm going to tell you about force. So if you want to know about that, make sure to stay tuned. So in this video I'm going to tell you about force and frictional force. But let's start with the normal force first. So force is a push or pull done by a body. Push or pull done to a body by another body. So if you assume you are pushing a block with a certain mass for it to form acceleration. If you have done this, that means you have applied a force on this mass. So let me tell you the interactions of acceleration with mass and force. So assume you are pushing, for example, let's say you are pushing a 2 kilogram mass. And if you push it more intensely, the acceleration will be greater. And if you push it less and lightly, the acceleration will be lower. So this implies that acceleration is directly proportional to force. That is, when acceleration increases, force increases. And when acceleration decreases, force decreases too. So, and let me tell you the interaction of acceleration with the mass. And if you, so let's say that you are pushing with 20 Newton. I'll tell you about the Newton later. But let's say you are pushing a mass with 20 Newton. And if you push it with 20 Newton and if the mass is more, that means the acceleration will be less. And if you push it with 20 Newton too, and if the mass is less, the acceleration will be more. That is, it will be easier for you to create more acceleration. So this implies that acceleration is inversely proportional to mass, or acceleration is directly proportional to 1 over m, or 1 over mass. So let me tell you about the calculations, but before that I must tell you the formula of force. So force is equal to mass times acceleration. So if you want to know forces long SI units, you can simply multiply m. SI unit is kilograms over 1. It's the same if I make it over 1, obviously. So times meter per second square. So kilogram meter per second square. Kilogram meter per second square. So that is Newton. So we can say force's SI unit is Newton. So let me tell you the calculations, or let me ask you a question about the thing I've taught you before now. So the question says a mass of 30 kilograms was accelerated with 3 meters per second square. How much force is applied? So you can pause the video and do this question. So using the formula I have given you, you can solve these. So let's take the given ones. So we have the mass, which is 30 kilograms. M equals 30 kilograms. And it has accelerated with 3 meters per second square. And acceleration equals 3 meter per second square. So how much force is applied? So the required is, what is the force? Force equals how much? So let's do it. Using the formula I've given you, which is F force equals mass times acceleration, you can do this easily. The mass is 30. I'm just writing the coefficients and I'll write the units later. 30 times the coefficient of the acceleration is 3, and make a bracket, and we multiply it by the units. So 30 kilograms kilogram over 1 times meter per second square, which is 90 kilogram meter per second square. And this gives us that the force equals 90 Newton. So this is the answer. Let me give you another question. So the question says a force of 50 Newton is applied to form an acceleration of 10 meters per second squared. What is the mass? So I've told you the formula of force, but you can derive all of the formulas just by the one I've told you. So try to do this by pausing the video. Okay, so let's take out the given, required, and solution. So the given ones in here is the force, which is 50 Newton. F equals 50 Newton. And to form an acceleration of 10 meters per second squared. So the acceleration is 10 meters per second squared. What is the mass? So m equals how much? So I told you that the force F equals ma. So our goal here is to leave mass by its own. So we'll have to divide it by acceleration in both sides. And we'll get mass equals force over acceleration. So I'm going to write the coefficients first, which are 50 is the force coefficient and 10 is the acceleration's coefficient. And I make a bracket and write the units. So Newton is kilogram meter per second square. Kilogram meter per second square. Times, we'll have to write the reciprocal of this, which is second square over meter, because I'm dividing it. So second square cancels second square, meter cancels meter. So only kilogram is left. So mass equals 5 kilograms. So this is the answer.
Yes.
So you can see that the answer is mass equals 5 kilograms. So let me ask you one more question. So the question says a mass of 25 kilograms is pushed with the force of 40 Newton. How much acceleration will it form? So pause the video and try to do this question. Okay, so let me take out given, required, and solution. So the given ones are the mass, which is 25 kilograms, and it's pushed with a force of 40 Newton. force equals 40 Newton. How much acceleration will it form? So A is equal to how much? So we're going to derive this acceleration's formula too. So let's use forces formula first. So F equals ma, and then we divide it over m for a to be alone. So A equals F over m. So let's write the coefficients, which is force coefficient is 40 and the mass coefficient is 25 and times their units. Force is kilogram meter per second square, times 1 over kilogram. So kilogram cancels kilogram, so only meter per second square is left. So 40 divided by 25 is 1.6. So that means the answer is acceleration equals 1.6 meter per second square. So thanks for watching. Make sure to subscribe if you're new and like if this video was helpful. Bye.